Welcome to the DIY Honda Garage channel. The DTC P0299-00 indicates a turbocharger underboost problem within the Honda CR-V 2023 model year and later. This issue occurs when there is a significant difference between the expected target boost pressure and the actual boost pressure in the turbocharger system. The powertrain control module, often referred to as the PCM, identifies this abnormality and stores the DTC for future reference. Components such as the turbocharger, boost systems, and various valves related to the turbocharger are critical to monitor as they directly influence the boost pressure. Regular inspection and maintenance of these components is paramount to prevent performance issues. This guide will outline the troubleshooting process necessary to diagnose and rectify the DTC P0299-00, ensuring optimal vehicle performance. DTC P0299 indicates a turbocharger underboost condition, which means that the actual boost pressure is lower than the target boost pressure set by the PCM. The PCM, or Powertrain Control Module, is the brain of the vehicle's engine and manages various engine functions, including boost control. It measures the engine's performance by comparing the target boost pressure, which is the desired boost the engine needs to perform efficiently, against the actual boost pressure detected by the system. The turbocharger, located between the exhaust manifold and intake system, is responsible for generating boost by compressing the intake air, allowing for increased engine power. If any components in the turbocharging system, such as the turbocharger itself, the turbocharger bypass control valve, or the boost systems, experience failures or leaks, the vehicle's performance may degrade, prompting the PCM to flag the P0299 code. Localized inspections of these components can help determine the exact nature of the issue. The possible causes of DTC P0299 include a variety of issues, primarily stemming from the turbocharging system. One common cause is the presence of vacuum leaks that can occur between the turbocharger and throttle body, which would lead to inadequate boost generation. Additionally, damaged components such as cracked hoses, leaky gaskets, or misaligned pipes can significantly impact the engine's performance by allowing air to escape, thus lowering the effective boost pressure. Faulty sensors, including the manifold absolute pressure (MAP) sensor, may also lead to incorrect readings, confusing the PCM's assessment of the engine's performance. Other potential causes include issues with the turbocharger bypass control valve and wastegate control actuator, both of which play crucial roles in regulating boost pressure. Furthermore, problems within the evap purge system, which assists in controlling emissions, may inadvertently affect the turbocharging system and lead to underboost conditions. Symptoms associated with DTC P0299 often manifest as noticeable changes in the vehicle's performance and driver experience. The most immediate symptom is the illumination of the check engine light, which serves as a warning to the operator that there may be an issue requiring attention. Additionally, drivers may experience reduced engine performance, characterized by a lack of power during acceleration, making the vehicle feel sluggish and unresponsive. Drivers may also notice turbo lag, a delay between pressing the accelerator and the vehicle responding positively. This occurs due to insufficient boost pressure being generated by the turbocharger. Other potential symptoms may include unusual noises from the turbocharger, such as whistling or hissing, which can indicate air leaks or mechanical issues. Observing these symptoms promptly can help in timely troubleshooting and repair, ensuring that the vehicle remains safe and efficient to drive. For the first troubleshooting step associated with DTC P0299, begin by starting the engine and allowing it to reach operational conditions. The next action involves holding the engine speed at 3,000 RPM without any load. meaning the vehicle should be in either the park or neutral position to prevent any movement. While maintaining this speed, closely monitor the engine's behavior, particularly watching for the activation of the radiator fan, which typically indicates the engine is operating at a normal temperature. This step is crucial, as it not only prepares the vehicle for further diagnostic checks, but also allows the technician to gather initial data about the engine's boost pressure and performance at a controlled RPM. Capturing this initial data is beneficial for comparing it with the target parameters stored in the PCM's memory, enabling the technician to diagnose any discrepancies. If the radiator fan does not activate as expected, this could signify cooling system issues, warranting additional investigation. The second troubleshooting step involves inspecting the air cleaner element, as it plays a vital role in the vehicle's air intake system. The air cleaner ensures that only clean air enters the engine, promoting optimal combustion and performance. Begin this step by visually checking the air cleaner for any signs of damage or debris that could obstruct airflow. An obstructed air cleaner can significantly affect engine performance, contributing to a loss of power and potentially causing DTC P0299 to trigger. Furthermore, validate that the air cleaner element is properly installed. A misaligned or incorrectly fitted air cleaner can also lead to similar performance issues. Performing this inspection thoroughly will ensure that incoming air remains unimpeded, allowing the turbocharger to generate the necessary boost without interference. If any issues are detected during this inspection, it's essential to replace or repair the air cleaner to restore proper vehicle functionality. The third troubleshooting step focuses on the turbocharger bypass control valve, an essential component that regulates the exhaust flow into the turbocharger. Begin by checking this valve for signs of leakage or damage, as such failures can severely hinder the turbocharger's efficiency. A malfunctioning valve may not open or close properly, causing the turbocharger to fail to achieve the required boost pressure, thereby triggering the DTC P0299. It's important to ensure that the valve operates smoothly. Any stiffness or irregularities during manual movement should be noted, as they might suggest a problem. If a visual inspection shows no issues, subsequently perform a function test using the Honda Diagnostic System, HDS, to confirm operational integrity. If the valve fails this test, it should be replaced to ensure that the turbocharger can perform as intended, allowing for consistent boost levels and improving engine performance. The fourth troubleshooting step involves examining the evap canister purge valve, which is crucial for emissions control within the vehicle's fuel system. Begin by inspecting this valve for any visible leaks or obstructions, which may interfere with its operation. A faulty evap canister purge valve can cause excessive pressure to build up in the fuel tank, leading to performance issues such as reduced power output or triggering DTC P0299. To assess its operational efficiency, activate the valve and listen for any irregular sounds, indicating possible malfunction. Additionally, verify the connections and hoses attached to the valve for any signs of wear or degradation, which could lead to further leaks or failures. If leaks are identified, it's imperative to replace the affected components to restore proper functionality of the valve, ultimately contributing to the overall performance of the turbocharging system. The fifth troubleshooting step entails inspecting the evap purge system, which is vital for controlling emissions effectively within the Honda CR-V. To begin, carry out a thorough visual inspection of the system for any signs of leakage around hoses, tubes, and connections, as these can contribute to abnormal pressure readings and impacts on engine performance. Identify common leak factors, such as loose connections or damaged components, that could result in pressure loss. Utilize diagnostic equipment to further assess the system's integrity, ensuring that all components are functioning within specified parameters. Failure to detect leaks can exacerbate issues with the turbocharging system, as they may lead to incorrect air-fuel mixtures and insufficient boost pressure. If any leaks or damages are found during inspection, address them promptly to maintain compliance with emission standards and improve overall vehicle performance. The sixth troubleshooting step requires inspecting Boost System 1, which bridges the components of the turbocharger and throttle body, ensuring adequate airflow. Start by conducting a visual examination of the hoses and fittings in the boost system for any signs of wear, damage, or leakage. Such abnormalities can lead to a significant reduction in boost pressure, thereby causing performance issues such as those indicated by DTC P0299. Any connections should be tight and hoses should be free from cracks or deterioration. During this inspection, use diagnostic equipment to measure boost pressure while the engine operates, verifying that it matches the expected levels set by the PCM. If any leaks or failures are identified during this step, they must be rectified before further testing to ensure both the turbocharger and engine can perform optimally. The seventh step involves inspecting Boost System 2, which plays an equally critical role in managing the pressure provided by the turbocharger. This inspection begins by examining the components for any blockages or leaks that may impede the flow of air necessary for maintaining boost levels. Utilize diagnostic methods, such as a pressure test, to ensure that the system is free from obstructions, and confirm that the components are secure and intact. Any blockages, whether from dirt, debris, or degraded parts, can disrupt the air supply, resulting in the underboost condition flagged by DTC P0299. Carefully check hoses, clamps, and joints during this inspection phase, ensuring every aspect of the system operates in unison. If abnormalities are found, they should be resolved to restore balance in the entire boost system and enhance engine efficiency. The eighth troubleshooting step focuses on the exhaust system, as it must be functioning correctly to maintain optimal turbocharger performance. Begin with a thorough inspection of components located between the engine and the muffler outlet. Look for potential sources of leaks or damage that could adversely affect the back pressure within the exhaust system, disrupting the turbocharger's operation. Common leak locations include joints and gaskets where connections are made, as these areas are prone to wear and misalignment over time. During this phase, pay attention to any unusual sounds that may indicate exhaust leaks or abnormalities in the system. After completing the inspection, conduct a test drive under controlled conditions to see if the symptoms persist. If any issues are detected, remedial actions must be taken to repair or replace the faulty components, ensuring optimal exhaust flow and turbocharger performance. The ninth troubleshooting step involves performing a functional inspection of the turbocharger wastegate control actuator, which regulates boost pressure by controlling exhaust flow. This functional inspection is best executed using the Honda Diagnostic System, HDS. Connect the HDS and follow the prompts to test the actuator's operation, ensuring it responds to commands properly. A well-functioning actuator should move freely and correspond accurately to the control signals from the PCM during testing. Any irregularities, such as a failure to move or excessive noise during operation, could indicate that the actuator is faulty and may be a direct contributor to the underboost condition linked to DTC P0299. If the actuator is determined to be non-functional, replacing it will be necessary to restore adequate boost levels and improve overall engine performance. The 10th step involves testing the turbocharger bypass control solenoid valve, which is crucial for managing the boost pressure. This test can start with the HDS, which allows for real-time diagnostics of the solenoid's function. When testing, listen for a clicking noise from the valve during operation. This sound indicates that the solenoid is functioning as intended. If no sound is heard, it suggests the solenoid may be defective, necessitating further inspection. Confirm that there are no obstructions or damages present on the solenoid or its connections. Taking this diagnostic step can clarify whether the control solenoid is a contributor to the turbocharger underboost issue reflected in DTC P0299. If it's determined to be faulty, replacing the turbocharger bypass control solenoid will establish proper airflow management and restore the vehicle's functional integrity. The 11th troubleshooting step is conducted only if all other inspections have yielded normal results, indicating that the PCM might be the root cause of the DTC P0299. By analyzing the parameters that govern boost control, including readings from the map sensor and other critical data, technicians can determine whether the PCM is interpreting data correctly. Use advanced diagnostic tools to confirm that all input and output signals from the PCM are functioning as specified. If discrepancies are observed during this analysis, it may indicate that the PCM is defective and could require reprogramming or replacement. Addressing PCM issues is fundamental to maintaining seamless engine operation, as this component orchestrates numerous systems within the vehicle. Ensuring that the PCM functions accurately will alleviate recurring faults and enhance the overall reliability of engine performance. The final repair verification step is essential to guarantee that the issues leading to DTC P0299 have been resolved effectively. After all repairs and replacements are made, it is crucial to conduct a thorough recheck of the entire turbocharging and boost system. Begin by ensuring that there are no pending DTCs and that the previously flagged P0299 code has not reappeared. Following these checks, perform a test drive under varying conditions to confirm that the engine's power output is consistent and meets performance benchmarks. Pay special attention to any symptoms that previously indicated issues to ensure they have been adequately addressed. If the vehicle operates as expected without any warning lights, this signifies a successful resolution of the issue, reinstating the vehicle's optimal functionality. Preventive maintenance is critical to ensuring the long-term health and efficiency of the turbocharged engine in the Honda CR-V. Regularly inspecting the air intake system, including the air cleaner and associated hoses, can prevent common issues related to airflow and filtration, which are vital to maintaining adequate performance. Additionally, monitoring the turbocharger's performance through scheduled diagnostics allows for early detection of any anomalies that could lead to underboost conditions, such as those indicative of DTC P0299. Components should be replaced promptly if any damage is found during inspections, particularly those that are integral to turbocharging, including valves, hoses, and connectors. Consistent preventive maintenance activities will not only prevent the occurrence of such codes, but also enhance the overall efficiency of the vehicle, leading to better fuel economy and driving experience. In summary, DTC P0299 represents a significant issue concerning underboost conditions within the turbocharging system of the Honda CR-V 2023+. Properly diagnosing and addressing this error requires a systematic approach. Please like and subscribe to the channel. See you next time.